Hello everyone. So today we'll be talking about bivariate data and scatter diagram. So let's start with bivariate data. So we all know that bi means two and variate means a random numerical variable. Any value that keeps on varying, right? So that is variate. And when we need to compare two related data variable to one another from a specific context, like if we want to study there's some relationship or association between two variables, okay, it is known as bivariate data analysis. For example, we need to compare a group of people's height to their weights. Like, is there any relationship between height and weight, right? Or association or correlation. So that is where we're requiring two variable data set. Okay. So, and also we suppose we want to compare number of umbrellas sold on a day to the temperature on that day, right? So definitely we have talked about how, why we, if we need to compare, we need to make a comparison, like is there any connection between two variables. Definitely we need to have two variables, right? So the connection is described using a variety of interchangeable synonyms, right? When we talk about two variables, like is there association between temperature and umbrellas sold, or there's a correlation between umbrellas and temperature, and or is there any relationship between the sales of umbrella and the temperature on that day. Okay, so we can use any term to describe the connection. So now let's come to a scatter plot. So what is a scatter plot? So as you can see in the picture, right, so it is nothing, it is basically a chart where you plot two variables, one variable on x-axis and one variable on y-axis. Okay, for example, this is a chart showing the size of jacaranda saplings over 8 months. So what we are comparing over here, what, like we are comparing age of the plant and size of the plant, right? Like suppose age is between one, during first 10 days, we say the age of plant is 10 days, and what is the size of that plant, that is height of that plant, right? So scatter plot is used to graph one variable, that is age, against another, which makes it easy to make judgments about the relationship between two variables. So we can see, suppose we have plotted all the values, and now we need to see is the size of a plant is growing as the age is increasing. We can definitely say yes. Like for example, when we say that when the age of plant is 50 days, the size of plant has increased. And when we are talking about 100 or 150 days, we can see an increasing trend of jacaranda saplings, right? So there are a few key points that we need to remember when we talk about scatter plot. So it is typically the variable which may be caused by other variable is graphed on y-axis. So as we can see, we can see that age of plant will be a key variable that will determine that will impact the size of plant. So here we took age of plants on x-axis and size of plant on y-axis. Okay, so now there's also another thing, right? We have to distinguish between the cause and effect, causation and correlation. We'll be talking about this thing in much detail in our next video. So it is of utmost requirement that we need to mistake a relationship with the cause and effect. It may happen that one thing is causing other, and we can see a positive trend or relationship, positive negative trend or relationship between two variables. But when we are plotting scatter plot, or we are talking about correlation, it may happen we are plotting two entirely different variables. For example, you can see here ice cream sales versus bushfires. Though we can see, if we have plotted these two variables like ice cream sales and number of bushfires, we can say that we can see a relationship or correlation between these two variables, but it may be caused due to rising temperature, right? So there's a third variable, which is cause of these two variables. So if you're plotting a scatter plot, right, it doesn't mean that there should be a cause and effect relationship. We can plot two variables just to find out correlation as well. Okay, so that is why causation is not to be mistaken with correlation. Okay, so here we can see there's a definitely a relationship between the two variables. What one is not necessarily causing the others. So when we talk about a scatter plot, we have to, you know, take care of three things. Like suppose if I'm looking at this scatter plot. Okay, so how to describe this scatter plot? We have to take care of three things. First is form. Okay, so if the scatter plot forms a shape that will fit best to a linear model, it is described as linear. For example, we can see here all the scatter are the dots that we have plotted. They are following a linear kind of trend, right? These lines you need to understand right now. We basically just plot the dots, right? And points basically, and the line will be talking about in regression analysis in much detail. Okay, so if we can see the type of what is the form, right, that our plots are taking. So we can see it is a linear kind of shape. So we will say the relationship is linear between two variables. And on the right hand side, you can see the scatter plot forms a shape that will fit best to a curve, right? If it is forming kind of, curve formation, then it will be a non-linear, right? And second determinant that we require to describe our scatter plot is direction. Okay, so if we can see that if x is increasing, y is decreasing, right, and vice versa, then there's kind of negative relationship between two variables. Okay, so if a scatter plot forms a shape that shows that x value increases, y decreases, basically there's an inverse relationship between these two. So it has a negative direction, right? And when we talk about this graph, okay, we can see as the value increases, okay, so as value of x is increasing, value of y is also increasing. We can see the trend. So there's a positive direction. Okay, so and third determinant is strength. Okay, so strength basically how closely our dots are clustered, okay, on our scatter plot. Okay, if they're quite close, then we can describe our relationship as a strong relationship. Okay, so if their plots are scattered, right, then we can say it is a weak relationship, right? So here we can see that it's a strong relationship, kind of moderate relationship, because dots are scattered, but only a bit scattered. And during weak relationship, dots are quite scattered. And when there's a no relationship, we can see the scatteredness is more. Okay, so we have to take care of form, strength, and direction. Okay, so suppose when we talk, we need to explain this diagram. So we can say, what is the form? Okay, when we talk about, now we have, when we plot this line, right, we have to take care of one thing, that we, draw a line, okay, where all the points are equally distributed above and below the line. And majorly the point should be on the line. So we can say it is kind of linear relationship, right? And what is the direction? Yes, you're right. Direction is positive, right? As the x is increasing, y is also decreasing. And when we talk about strength, it is we can see they are not so closely cluttered, right? So clustered. So we can say that it is a moderate kind of linear and positive relationship. Okay, so that's all. When we talk about scatter plot, we have to take care of three things: form, direction, and strength of the scatter plot. Okay, so you can see to describe a scatter plot, all three characteristics, form, direction, and strength, should be covered. Okay, and here we can see a scatter plot where correlation is strong, positive, and there's a linear association, relationship, or correlation between two variables. Okay, and now outlier. Now what are outliers? See, when we have plotted all our values, but there are one or two values which are um, you know which are not basically fitting our trend, right? Like for example, suppose when we are measuring the BP, right, and we are plotted, right, age and BP, there are few dots that are quite away from other values, right? So those values are basically, they are not exhibiting the normal behavior or a normal trend, so they are known as outliers. Okay, so when we talk about how to define outlier, when you describe the correlation using three key terms, like what kind of relationship it is: moderate, positive, and linear. But we can see that there are 2 points here that are not fitting the trend. Okay, so outliers can be caused by many things, including errors in the data set, or there can be some anomalies of life or nature, right? So this is about outlier in brief. Okay, so so other has a much here, when we talk about here these two outliers. Okay, so this outlier has much higher dependent variable as compared to other. So this is majorly x variable is we call it as a independent variable, and y axis we plot independent variable. Like this is basically we are plotting taking as a major variable, right? So the other, when we talk about this variable, right, this outlier has much higher independent variable, right, as compared to dependent variable. So like how we can definitely make a scatter plot. Okay, on an Excel sheet, you don't need to, put in extra efforts. You have to just, write down values, which we'll see in the later part of the video. Or you can simply plot a scatter plot on your graph sheet as well. So you can see in this particular question, suppose you need to create a scatter plot for the following data set, your X variable and Y variable, right? First, you have to see what X values you need to take, right? So here you can see the minimum value is 3 and it goes to say 6.3, the highest. So you can plot the graph like this, right? So 3 to till 7 we have taken the values, and when we talk about y values, they are starting from 25, right? So we can basically start from 20. Okay, we can take the partition value as 10, 20, 30, 40, 50, right? So let's plot. Okay, so when x value is 3, right, y value is 25. So when x value is 3, y value is 25. Suppose we are plotted here, right? And when x value is 4.1, right, when 4.1, then again 25, right? And when x value is 5, y value is 50, x value is 5. So here we have taken value as 50. Okay. So then we have 6, and then we'll plot it to 29 right here, 6 and 29. So you don't need to draw these lines. I'm just explaining you how to put values on the graph. So you have to just put dots on the points corresponding to x and y axis value. Okay, like we have already learned during our school, like how to plot 0.23 on the graph, right? So we have to just plot uh, uh, x and y points on this graph. Okay, so these values become our x values, these values become our y values. And after plotting the graph, we have to take care of three things while explaining about our scatter plot. So what we have to take care of: form, direction, and strength of the relationship, right? So uh, that's all for this video. Okay, so